Alright, welcome back to my channel. In this video, we are going to be treating the application of first order differential equation to temperature. And then the question here said that a metal bar at a temperature of 100 degrees Fahrenheit is placed in a room at a constant temperature of 0 degrees Fahrenheit. Then we are asked that if after 20 minutes that the temperature of the bar is 50 degrees Fahrenheit, then we should find a question, the temperature it will take, the time it will take the bar to reach a temperature of 25 degrees Fahrenheit. Then secondly, we should calculate the temperature of the bar after 10 minutes. Now we are going to be using the law of cooling. The law of cooling states that the rate of change of temperature with time, okay, that is the change of temperature with time is directly proportional to the change of the temperature from directly proportional to the difference of the temperature of the body with the temperature of its environment. So that this is directly proportional to the what? The temperature of the body minus the temperature of its environment. Okay? And that is the surrounding media. So that is that. So this one is the temperature of the surrounding media. That is its environment. Why this one is the temperature of the body you are talking about. So in this case, the temperature of the bar is known as T. And the temperature of its surrounding, that is the room, is now the what? The Tm. Now, since this is cooling, how do we know that it is cooling? You will see that the initial temperature was 100, and then after 20 minutes, the temperature became 50. So since it is cooling, we are going to have that the T over what? The T will now be equal to minus R into what? T minus what? Tm. Okay? So you should know that when you remove proportionality sign, you are bringing in a constant. And the constant is going to be negative if you are talking about cooling. But if you are talking about heating, that the temperature increases, maybe after 20 minutes, that the temperature increases from 100 now to maybe 120, then you now know that this is talking about heating. So if it is heating, the arrow is going to be positive. So know the difference between them. Okay? So since we have this, let us apply what we have. If you look at this, you see that the initial temperature of this body is 100, and then the temperature of the surrounding is 0. So putting 0 here, I'm going to be having that the T over the T will now be minus RT. Why is it? Because here is 0. T minus 0 will give you this. So this is separable. Since it is separable, I'm going to be having that what? The T over T is equal to what? Minus R dt. If I integrate both sides, I'm going to be having the integral of 1 over T is equal to what? The integral of minus R dt. So having this, we will now integrate both sides. So we have the integral of this, we now have, there is the T here. So integral of this will give you ln T is equal to the integral of this will give you minus RT plus a constant. If you take the ln of both sides, so the exponential of both sides, I'm going to be having that T staying itself will be exponential minus RT plus a constant, because when ln moves to the other side, it becomes exponential. So this becomes that T will now be what? Exponential minus RT multiplied by exponential C. And the exponential of a constant is a constant, so we have that T becomes T naught exponential minus RT. Okay? So, and our T naught is the initial temperature, which is what? 100. So we have that. Now, so let us apply everything we have. In 20 minutes, that is T being 20, it was 50. So the current temperature, which is this, is what? 50 is equal to what? The initial temperature, 100 exponential minus 20 times R, which will give you 20 R. Okay? The time here is 20, and you multiply by the rate. So having this, you see that my answer becomes that exponential minus 20 R will now be equal to what? 50 divided by 100. So I'm having that what? Exponential minus 20 R becomes 1 over 2. So therefore, take the ln of both sides, because exponential moving to the other side becomes ln. So minus 20 R will now be equal to what? Ln 0.5, because half means 0.5. So therefore, my R will now be what? Ln 0.5 divided by minus 20. So R, if you do that, you are going to be having that the rate here, press your calculator to have that the rate here becomes, what's the rate here? Okay? If you do everything there, you are going to be seeing that the rate becomes 0.035 becomes the rate, because lane 0.5 is giving us negative. Okay. So having this is our rate. So if we now put it in our equation, this is our equation. The equation becomes that t is equal to what? T naught exponential minus 0.035 t. Okay. So to answer the first question, question number A said we should calculate the time when the current temperature is now 25. So we now have that what? 25 is equal to, using this formula, the initial temperature is always 100 exponential minus 0.035 t. Okay, so we're having that exponential minus 0.035 t will now be equal to this divided by this, that is 25 divided by 100. So therefore exponential minus 0.035 t will now be equal to what? 1 over 4. So we're having that minus 0.035 t will now be equal to ln 1 over 4. Okay, so t will now be what? Ln 1 over 4 divided by minus 0.035. So if you do that, you will see that the time is going to take this man will now be 39.6 minutes. 39.6 minutes. As simple as that. So let us now solve the second question. Question number 2. So permit me to clean here to solve question number 2. For question number 2, the question number 2 here said we should now calculate the temperature. So we're looking for T now, which is equal to 100. Remember that our T naught is always 100. 100 exponential minus 0.035 multiplied by the time they gave us here is 10 minutes. 10 minutes. So I'm going to have that this is 100 exponential minus 0.35. Yeah, 0.35. So if you do that, you're going to see that the temperature will now be 70.5. 70.5 degree Fahrenheit. As simple as that. So thank you very much for watching this particular video. So we're going to solve more videos in more questions in our subsequent video. Please don't forget to like, share, and subscribe. May the peace of the Lord be with you. Bye-bye.